In section 12.3, you're going to work with arithmetic sequences and series. So I want you to be able to find the indicated terms of an arithmetic sequence and find the sums of arithmetic series. So linear functions have a constant first difference. We've talked about that several times. And since the ordered pairs, and I'm missing a couple letters in both of, or letter in both of these words here, of arithmetic, just squeeze an M in there, sequence, and squeeze a C right in there, form a straight line, and we'll look at that in just a minute below. You can think of an arithmetic sequence as a linear function with sequential natural numbers as the domain. Okay, so what happens if you list a sequence and the term number is 1, or the term number is your domain and the term value is your range, it makes a line. So here we can see that the differences are, common differences are 5, and I just kind of did a quick sketch here to show you that that was linear when you graph it out. Now, since we subtract from right to left, we're going to get 5 for the differences here. This sequence could be arithmetic with a constant difference of 5. Over here on the other side, if we do the differences, the first difference is not common. So that means the sequence is not arithmetic because the first differences are not common. Okay, general rule for the arithmetic sequences, and you've seen this before. So we're going to use that, and now today we're not always going to have a sub 1 here, or the first term. We might have the third term or the fifth term, depending on what we need to find, but just remember that n represents the term number. So it doesn't always have to be the first one, but what's going to happen, this n goes here, this 1 goes here. So if we change this number, then that 1 is going to change. Okay, and we have been putting the d in front here, so it really doesn't matter. Multiplication is commutative, so we can put the d here or here. Okay, so the first thing that we're going to try to find the 12th term of the arithmetic sequence, and this is the sequence that we're given. So the first thing that we're going to need to do is find the common difference, and when we do that, we're going to find that it's -6, subtracting from right to left. Okay, we need to have the first term, a sub 1, which is 20, and we're looking for the 12th term. So first we have the common difference, and we can use our arithmetic sequence. And when we do that, we want to now find the 12th term. So we're going to put a sub 12 here. That's what we're looking for. And our first term is 20, so that we're going to put that right here, a sub 1. And now we have the common difference, so we'll put that in there, which is -6. Now this was a sub 12. This is a sub 1. So instead of doing n minus 1, we're going to replace the n value with 12. So inside the parentheses, we have 12 minus 1. And then when we simplify that, we can figure out what the 12th term is in the sequence. Now, you might say, well, I can probably do it faster just by subtracting 6 until I get to the 12th term. Now, that may be the case, but if I asked you to find the 157th term, you certainly wouldn't want to do that. So we're going to simplify that, and a sub 12 is -46. All right, now, another thing that we can do with the arithmetic sequence is find missing terms in a sequence. So on the right here, I have a sequence that is 17, and then I have 3 blanks, and this should be a -7, so insert a negative there. And we want to figure out what these values are. Now, you might be able to see it quickly. It might take you a while. We could have a more difficult sequence where you can't find it. So these are the steps that I want you to find. The first thing I want you to find the common difference. And you might say, well, I don't have the terms inside here, and you're correct. But we can go back to the arithmetic sequence. You can use this for several different things. And we know we have the first term and we have the 5th term. So what we're going to do is we are going to say, okay, well, we're going to go back to the sequence. It's a sub n equals a sub 1 plus d times n minus 1. And we're going to use a sub 5 here because we know the 5th term. So we're going to do a sub 5 equals a sub 1 plus d times n minus 1. Okay, well, we have the first term, which would be here. We have the fifth term, which would be here. And now we're going to change that n to a 5. So these values inside the parentheses represent the subscripts to the left and to the right. The left one goes first. So now when we fill that in, we're going to fill in a sub 5, and again, change that to a -7. A sub 1 is 17. That's our first term. We're looking for the common difference, and we have to use the subscripts go inside the parentheses, so 5 minus 1. When we simplify that, we're going to get -24 equals 4D. Okay, so solving for D, we'll end up with D equals -6. Okay, well, now that I have that, I can just say, okay, we know that the common difference is -6. So if I go from here and do -7 minus a -6, that's going to give me a -1. And then -1 minus a -6 is going to give me 5. And 5 minus a -6 is going to give me 11. And now I have that missing sequence filled in. All right, another thing that you're going to be able to do, and it's similar to what we just did up front, if we're given two, or in the previous example, except we're using different term numbers, we're given the nth term, we want to find the nth term given two terms. So let's see, we want to find the fifth term of the arithmetic sequence with a sub 8 and a sub 14. So now we don't have an a sub 1. All right, so I'm going to do it a little bit different. I started typing it up like, but I'm going to give you a different technique to do that. So the first thing that we're going to use is the two terms that we have here. We don't have the common difference, so we need to find that. We have the 14th term, and we have the 8th term. So I'm going to say a sub 14 and a sub 8 plus d times, and what has to go in the parentheses are the two subscripts here, so 14 minus 8. And again, the reason why it was n and 1 before is because we always had n here and a sub 1 here. Okay,